All right, this is on the continuation of the previous lesson of 16b. So extreme values of the test stats are unlikely, so observing such a value is observing the evidence against the null hypothesis. However, we need a measure of just how extreme a value is. The p-value of a test statistic is the probability of that result being observed, H sub O, the null hypothesis that's true. So what does this mean? The meaning of extreme depends on where the alternative hypothesis is one-tailed or two-tailed. So this H sub 0, remember, is your null hypothesis. The alternative hypothesis, H sub 1. So if H sub 1, the alternative hypothesis, is one-tailed, we use a one-tailed t-test distribution to calculate the p-value. So here is your curve, and then there's your area under the curve, and then here's your t, and then this is your mean. If the alternative hypothesis is the mean less than the alternative, we use the lower tail. If it is greater than, then we would use the upper tail. Sometimes we have a two-tailed t-test. So here's the negative t, here's the positive t. Here's your area under the curve when your t is greater than 0. If your t is less than 0, here's your area under the curve. So for two-tailed alternative hypothesis, the p-value equation equals 2 times the probability All right, making decisions. Go ahead and pause the video and read this slide. All right, I'd like to read what's in this blue box. The significance level alpha, that's a Greek letter, of a statistical hypothesis test is the largest p-value that will result in rejecting the alternative hypothesis. Any p-values less than or equal to alpha results in rejecting the null hypothesis. If a statistical hypothesis test has significance level alpha, the probability of incorrectly rejecting the null hypothesis is alpha. The significance level may be given as a decimal or a percentage. So here is an example. In our insect repellent example from a prior video, suppose the researcher was concerned about any change in the average projection time. The researcher decides to test the hypothesis. So the average time was 6 hours, that's your mean, against the alternative hypothesis, that it's not 6 hours, and the significance level is 1%. So this is your significance level, 1%. This is your mean. For your null hypothesis, your alternative is that it doesn't equal 6 hours. So then we would use our calculator and the formula above in the purple here. So here's our formula, and we would get this answer. Since that p-value is less than, so our p-value is less than 1%, then we would reject the null hypothesis and accept the alternative, that the average is not 6 hours.